And we are delighted here at the Climate Discussion Nexus to be joined by Stephen Koonin. And before we start our conversation, I just want to specify first off, because people will make strange criticisms. Yes, you are a climate scientist. You are, in fact, have a PhD in theoretical physics from MIT. And since a critical part of the whole issue of climate change is how various greenhouse gases absorb and emit radiation, it seems like a physicist is just the thing to be. And the other point I want to make is that you're not one of those nasty right wingers who can be brushed aside. You were, in fact, a senior official in the Obama administration. But as you went along, and particularly it was a 2014 American Physical Society meeting, you started having concerns about how climate science was being done that resulted in you writing the book Unsettled, which is not about how everybody's dug in over there and they should be dug in over here, but it's about what we know and what we don't. So I want to start with this general. Why is it so important to understand what we don't know?
Well, good climate policy requires balancing the risks and benefits associated with growing human influences against other considerations, like the world's need for reliable and affordable energy. And in order to do that balance properly, you need to understand the subtleties, nuances of what we understand and what we don't understand. It is by no means a certainty that the world faces crisis, catastrophe, existential threat. And so I think the policymakers and general citizens really need to understand the subtleties, and that's why it's important.
And one of the things, if you listen to, well, the media, but also if you listen to a lot of politicians, they will say extreme weather events are becoming more common. But one of the critical things, and you have to go through various chapters on different aspects of this, from precipitation to hurricanes, is that in fact, in many cases, the data don't show that they're getting worse. And in many cases, the data are either not sufficiently complete or we don't have a long enough time series to have it really show us anything.
That's correct. And the public rarely sees the data. If you look at the summaries of the IPCC or US government reports or the popular media coverage, you never see the data, let alone put in the proper long time frame context. For example, I'll give you just one example. We saw terrible floods in Texas about a month ago. And when you look at the actual observer's record going back more than a century, you find that there was comparable rainfall and comparable river rise at that very location, Kerrville, Texas, going all the way back to 1900. And so, the statements of unprecedented due to human influences and so on are just not supported by the historical record.
But in fact, in the case of Kerrville, it's not just the last 100 years, but the geologists tell us it's thousands of years.
Sure, there's a good reason that region of Texas is called Flash Flood Alley, all right? And yet the media play it up, the politicians will play it up. And so that's why it's important for people to understand a bit about the science, which includes the long-term observational record.
Yes, and by the way, I mentioned at the outset this thing about not a climate scientist. I remember there was a news article at one point about Will Happer, where the authors said that he was not trained as a climate scientist. And so, first of all, Happer's an atmospheric physicist. But then I went and looked up what their degrees were in, and it was, the usual Latin American studies kind of thing. And I thought, maybe just a little humility here would be helpful, because if you start to write, if you're the climate reporter, as you say,
Jim Hansen is a physicist by training. Michael Mann has an undergraduate degree in physics, and he once applied to be my graduate student, by the way, a long time ago. So it's nonsense. Moreover, some of the criticisms that I and others level at the way climate science is presented is just straightforward, basic scientific method. I like to say it's like if a carpet guy came to measure your room, which was, let's say, 9 by 10 feet, and he told me that you needed 200 square feet of carpet rather than 90. I know that there's a problem. And the same kind of thing is true in our criticisms of climate science.
Yeah. And one of the things that I tend to harp on is that we get told that, last year was warmer than it was in the late 19th century and then they'll give you two decimal places. And I don't really think it's possible to measure the temperature of the Earth today to two decimal places. In fact, I think it would be a considerable challenge to do that in just one room of a house. But the idea that we know what it was, the temperature to two decimal places, 8 and 50. And would occasionally ask themselves, how was temperature measured 150, 170 years ago? Where was it measured? With what kind of instruments? What kind of thoroughness was there? And another thing that is, I think, very important about statistics, we were just talking about this at the Climate Discussion Nexus about hurricanes again.
Mm-hmm.
If you're trying to figure out if there's a trend, and if there's a lot of natural variability, you need a long time series. And that to me, it's so basic, and yet I don't think most journalists have ever heard this concept.
Right. They'll say it's the worst since 1960, but of course you naturally ask, well, what about before 1960? There's a wonderful example in the recent DOE report that I was a co-author on, where you look at extreme precipitation in San Francisco. And if you start the record at 1900 or 1895, you believe that the last few years have seen the most intense precipitation. But if you extend the record back to 1850, you discover that the recent years are fourth or fifth rank and that it was rainier in 1850. So the long record really makes a difference.
And by the way, I do get some grief from people sometimes because my academic training is actually in history. Though I am not incompetent at math, but I gave up on linear algebra as a way of understanding so much that we need to know many years ago. But I say, when I first heard about this whole idea that it was becoming unprecedentedly warm, my thought was, well, what about the medieval warm period?
Right.
And,
Yeah.
and and we hear hottest year ever. What about the Holocene climatic optimum? Do you really not know? Or are you doing something a little less honest?
The climate system has tremendous variability on all scales. And the challenge in trying to isolate the response to human influences is to have that variability under control. Uh, we've seen warming since about 1975 or 1980 at what is alleged to be an unprecedented rate, but we don't really know what the rate was going back even to 1900. And so a little bit of humility is really important in looking at the historical records.
And there you anticipated partly my next question, because one of the issues, of course, is that we only have digital thermometer readings going back a few decades. Then we have pretty good instrumental readings in some places going back maybe into the late 19th century. But the proxies that we use to try and estimate temperature in the 14th century or in 49 BC, it's not just a matter of them being imprecise, but they also don't capture the short run. So we really don't know. We have no way of knowing how quickly it has typically warmed over 50 years, even as a blip, since the Holocene began.
Right. That's certainly true if you focus on temperature. And of course, there's no global coverage. So all you've got is rather poor proxies or isotope ratios and so on. The longest instrumental climate record we've got, one I like to show often to people, is the record of the height of the Nile over about 800 years in ancient Egypt from about the 7th century to the 15th century. And there you see a lot of interannual variability superimposed on long-term cyclic trends, not really cyclic, but long-term up and downs, that could fool you and probably fooled the ancient Egyptians when it looks like it's going into drought for 100 years, and then the natural variability brings it back up again to a wetter period. So again, humility in interpreting climate.
And when you mentioned the Nile, my first thought was that the historical record has people going, oh no, here it comes again. Because one of the things you realize if you look at history is that the weather has been bad, and farmers have been complaining bitterly about it since the invention of the hoe. And so one of the things people say, oh, look, the weather's bad. This must mean something terrible has happened. It's like, but you know, if again, if you were asking the Vikings about the weather, or the ancient Romans, or I don't know, people in Crete, or the Egyptians, like, how's it going? It's like, oh, 7 lean years. You can't believe we're all starving.
And when the weather goes bad, the natural human impulse is to pray and offer sacrifices. And you might argue that our modern attitudes about climate are exactly that, at least with respect to the sacrifices.
There's actually an anecdote about Calvin Coolidge, your last truly libertarian president, having farmers come to see him with the usual, oh, you know, the prices are too low, the varmints are everywhere, we've got it, you know, this terrible, all this stuff's happening. And when they're done, Coolidge says, better get religion.
Yeah.
His idea of a
Right.
government program.
Yeah, right, right. Or just wait a decade and things get better. Right?
Yeah.
Reversion
Now, and
to the mean.
speaking of history, in the book you talk about the fact that you were actually, back when they were not what we would consider computers, but they had been invented, you were given a computer by somebody who just said, do something interesting with it. And then you wrote one of the very first textbooks on computer modeling. So one of the things that you know more about, it seems, in the people who comment on it, and even the people who use it, is the limitations of the models.
Yeah, and how you check and validate or not the computer models. I also have some experience with that as I've been involved with the U.S. National Laboratories, who do a lot of computer modeling, not unrelated to climate issues, in the context of nuclear weapon stockpile uh, stewardship. And you know, I understand that there are knobs in computer simulations that can be turned to adjust the output. I understand that you need to validate your results against observations, and so on. And uh, that often is not done in climate science. You know, the modern suite of computer models, CMIP6, shows a factor of 3 variation among the various models in the climate sensitivity. And that's a pretty shaky basis on which to be making policy decisions.
Yes, and of course, one of the problems, because computers seem so impressive, right? And we're very much in the grip of Galileo's that mathematics is the language the universe is written in. And so we want the computers to tell us exactly, including in economics, you know, if we were to raise the minimum wage by 18 cents, how many hundreds of people would get jobs or wouldn't get jobs. And often the subject just doesn't permit that, because the way they make these models with these, all these blocks that are, you know, quite large, whereas the processes, including cloud formation, are a sub-grid scale. And so it's not based on a rigorous understanding of how the factors interact, but a sort of, let's just take a guess, run it, and if it's way off, we will, as you say in the book, tune it. But this tuning is like, our intuition guides us to make the computer tell us what we think it should have told us, not we start with the laws of physics and out comes the prediction.
So if you're trying to model planetary trajectories, for example, or spacecraft trajectory in the solar system, you can do that with great accuracy, because there aren't very many things you don't have control over in a numerical sense. The climate, however, you can't model every cloud, and so you've got these subgrid scale issues, and you've got initial conditions, like what's the state of the ocean deep down, where the ocean circulations determine the multi-decadal timescales. We don't know that either. So it is an imperfect business. And as the professionals have said in print, they give us only a very hazy picture of what the global future might be. And at the regional level, they are entirely unfit for purpose.
Yeah, and
It's
to make
terrible. It's terrible.
to make a polemical comment here, because you also mentioned in the book that the models really can't deal with that early 20th century warming and then the cooling period. And my answer is, well, no, because they were designed by people convinced that CO2 is driving warming. And so that's what they're going to tell you no matter what the inputs are. And so all the computer's telling you is what you told it to tell you. And I've seen people making economic models, and much the same thing is happening. So it's, like sausages. You maybe don't want to watch it if you like them.
As an illustration of what the models can't do, since the year 2000, so for the last 25 years, we have seen a decrease in the Earth's reflectivity by about 0.5%. And or equivalently, its albedo has gone down. And you might say, well, 0.5%, not such a big deal. But in fact, that's equivalent to the radiative forcing for just about as much as CO2 causes in total, about 2 watts, 1.5, 2 watts. All right? And none of the models predicted that. And we really need to work very hard to understand it. So there are mysteries at the level of the thing we're trying to understand, namely the response to CO2, that are first order. And, I don't see how you can say what the response is to CO2 if you can't understand those phenomena.
Well, yes. I mean, it's one of the things about the models. Javier Vinos, he was a guest on one of our webinars, and who had turned to climate after a professional career in a quite different field. So he came to it with good scientific understanding, but sort of clean slate mentally. And then at one point, he made a list of all the things the models can't do. And to be blunt, they really can't do anything except tell you CO2 causes warming, because that's what they were designed to do. And that's no way to make science.
Right. I believe, and several other mainstream climate scientists, senior people, have said we've been doing too much computing and too much modeling. We're running, infinite number of scenarios for the IPCC and so on. I think we need to go back to pencil and paper, or perhaps spreadsheet or PC level understanding before we get involved in all these big models again. Back off and ask, do we really understand this? What are the basic principles?
Yeah, and again, linear algebra has done great things in the last 500 years. It's why jet airplanes fly and so on. And so we can become too confident in its abilities. But again, speaking as a historian, though only of the recent past, I remember, in the late 80s and early 90s, chaos theory suddenly became trendy. It was James Gleick's book Chaos, which I thought was an excellent coffee table introduction. And everybody was getting the butterfly effect, and this fact that a lot of important things are sensitively dependent on initial conditions. That with linear algebra, if you're close enough on X going in, you're close enough on Y coming out. But when the butterfly flaps its wings in Beijing and 3 days later there's rain, not sunshine in Central Park, you've got these complicated feedback systems. And to me, again, I mentioned, having done very well at math in high school, but I went to university and I studied history, and then I did work at an economic think tank. But and I have great admiration for these people, but we parted ways because they were too much into modeling and linear algebra, and I'm what's called an Austrian economist. I believe that incentives matter and things like that, but I don't think mathematics is going to tell you anything intuition doesn't tell you. And another of the things that you have in the book, and again, if only journalists knew about this and knew why it mattered, it's this thing Ed Lorenz had happened to him back in 1961, again, when computers were wound with copper, and we would wait forever for nothing. And so he'd run a simulation, and then he wanted to do it again, but he didn't want to wait while the thing ground slowly. So he just took the output, plugged it back in, and ran it, and it diverged dramatically.
So we know that the weather is chaotic. I mean, that's proven by the fact that we can't forecast more than 5 days sensibly, maybe 6 or 7. Climate, I think it's yet to be determined whether the climate is chaotic or not, or just how deterministic it is. So yes, that's another part of the problem, is the chaos. So initial conditions, subgrid scale, and chaos are the 3 devils, if you like, of detailed climate modeling.
And I was looking at this because of the Milankovitch cycles, right? And this puzzle with glaciations in the Pleistocene, that they seem to be happening every 41,000 years, and then they switch to 100,000 or roughly. And one theory that somebody had come up with is actually it's about a 20,000 year cycle, but some of them don't quite hit critical mass. They don't reach that tipping point, and so you don't get another interglacial. But the fact is, we don't even know that, right? So there's a sense in which, even though we know there's a periodicity here, and we know that it's to do with the tilt of the Earth and things that are fairly well understood, though those feedback loops, they're just so devilish.
And the glaciations are like hitting the climate system with a hammer. The insolation on the northern part of the Earth, the northern hemisphere, goes up to 60 watts per square meter above average, sometimes more. Whereas the CO2, or the human influences more broadly, are 2 watts per square meter. So the whole climate discussion these days is about a very small perturbation and how the climate system responds to that. And as you correctly point out, we don't even understand well how it responds to 60 watts per square meter.
And an interesting thing about this, that the alarmists do have hold of one little bit of chaos theory, which is that they argue that there are tipping points, that certain processes will trigger a runaway warming disaster, but they don't seem to believe that there's any other kind of tipping point or that these are an obstacle to modeling. And when people talk about, carbon sequestration and so on, one of my concerns is, well, what if there are tipping points the other way? What if you trigger a glaciation? You'd look pretty silly.
Yes, it's true. Although, the glaciation is not so much determined by greenhouse issues as by the orbital mechanics changing the insulation, how it falls on the Earth. But, if we reduce CO2 too much, the plants are going to crash, right? That happens at about 180 parts per million. We are currently at 430. So if you really want to draw down CO2, as some people claim we should be, you better be careful about how far you go, or you crash the plants.
Well, I mean, I was just in Senegal, right, which is a very poor country with unfavorable conditions for agriculture in much of the place. And we saw camels, right? You may think Africa's all jungle. Well, I promise you it's not. And one of the consequences, if we were to achieve this goal, which again, I think it's hubristic to think that we could, but if we did, is that we would condemn millions, maybe even billions of people to starve because of the impact on agriculture. And you better be very sure that what's happening now is leading to apocalypse before you do that as a preventive measure. People will often say to me, oh, well, we shouldn't take chances. But the problem is that often the policy response takes a very big risk for a minimal payoff.
Right. It's kind of a one-issue policy discussion for many people. They don't understand the trade-offs. And there's also unrealism about what's actually possible in mitigating emissions. There's also a more policy relevant question about denying roughly half of the world that needs more energy, denying them affordable and reliable energy. And that's very much a Western cultural mindset. And to me, as I've come to understand the problem, it is so immoral to be thinking about preventing people from emitting CO2 because they're using fossil fuels.
Yeah, I mean, I don't want to give away the plot, but while we were in Senegal, we visited one village where they do have solar energy, but they said it just fizzles out when the sun goes down.
Right.
And they said, and then we keep the kids indoors because there are snakes and scorpions. And they showed me footage of this snake they'd killed that morning that was a lot taller than I was. And again, these are homes that don't have indoor plumbing. And this is, North Americans are all fine and good about, oh, yes, we'll definitely, go to net zero provided we get to keep our air conditioning. But as you say, the impact on these people's lives, it is monstrous. And I was also thinking, imperialism, it's not just for Cecil Rhodes anymore.
Right. Carbon colonialism, right. This is one of Chris Wright's, the current energy secretary's, major points. The world needs more energy. Rather than less. And the only way you're going to get that really is by fossil fuels in the next few decades. So let us do that.
Yeah. And now to retrace a little bit, because you were talking about CO2 and greening. And of course, this is in the DOE report. There's a good deal of attention given to that because it's an important phenomenon, factually, reasonably well documented. But as one of your co-authors, Ross McKittrick, has been particularly energetic in documenting, it isn't talked about by the alarmists. And this leads me to this whole issue of something that leaves a bad taste in the mouth about the way they approach things they know about. But and you mentioned one of these in the book where you shouldn't say it out loud.
Yeah. So I just again a recent anecdote. I have a good colleague who's a very accomplished physicist, but is not climate savvy. It's just not his field. He read the report and he said, "My gosh, I didn't know about that greening. How come I never hear about it?" And so there is a reluctance to talk about the benefits of CO2 or of warming. Another one is that there are fewer people who die from temperature extremes because a lot more people die from extreme cold than extreme heat. And as the globe warms, the extreme colds get less, the extreme heats get a little more, but more people are alive because of the warming than would be otherwise. You don't see that at all in the IPCC summaries, certainly, and it's barely there in the report itself. So the alarmists don't want to talk about it.
Yeah, and you certainly don't see it in the popular press. I mean, I was astonished to learn. Years ago, I traveled a bit. I backpacked around India. More people in India die of cold than of heat, which you'd think would take some doing because India is quite a hot place.
It won't, yeah.
But of course, it's not really. I mean, you can get on the media because they're meant to be skeptical, right? In the old days, the pork pie hat, the fifth of bourbon in the desk drawer, and why is this person lying to me? They've become very credulous, but to some extent, if the professionals won't come clean about the uncertainties and about the doubts and about the things we wish we could do better and about the things that are actually better because of warming, then the press gets a partial free pass. And again, this American Physical Society, this was in 2014, and this is where you suggested the red team, which I think, which is again, which you've just done. But I'd like you to tell the audience a little bit about that experience and how it got you determined to say something, even if people called you ugly names, which they do.
Which they have, even more so in the last week or two.
I'll bet.
Okay. But so in 2013, I was the vice chair of an American Physical Society committee called the Panel on Public Affairs. And the society had issued a statement about climate change, I think in 27 and refreshed it in 2010, with great controversy because it used the word incontrovertible, which to physicists is a fighting word because we have pretty high standards for statistical significance. And so in 2013 or 2014, it was time to refresh the statement, and I was put in charge of a committee that would recommend a new statement or an updated statement on climate change. And my training, which came from Caltech and Dick Feynman and, the natural skepticism that is supposed to be characteristic of good science, I said, we are not going to take anybody's word for it. We're going to go through the then new IPCC report AR5, and we're going to have a workshop in which we will have three supporters of the consensus, the IPCC, and three credentialed skeptics. And we sat for a day in Brooklyn in early 2014, had presentations from the 6 climate scientists involved, and we sat around and listened and asked questions. It's all recorded on a transcript, which you can find on the web. And I came away from that discussion feeling that the science is nowhere as settled as had been portrayed to me, because I never really looked to it in great detail. When the committee convened and tried to formulate a draft statement, I tried to inject the appropriate degree of caution and humility. And one of the committee members said, that's all true, but we can't say it because it'll give ammunition to the skeptics. And my training as a scientific advisor in other fora, that's anathema. And eventually I wound up resigning from the committee and writing a big op-ed in the Wall Street Journal about the uncertainties that were in the science at the time. So that's really what got me started on wanting to see that the decision makers, the non-experts, be given an accurate portrayal of the certainties and uncertainties in the science. Eventually, it led to writing the book and the current trajectory that I've been on.
Which is what an object lesson. If only the people there had listened to you, perhaps you would have been content to
Maybe.
get your licks in and go back to the lab. I mean, it's always find it interesting as a person who's kind of sought out controversy since I was young. I mean, I loved high school debating and stuff. That I encounter people. I think Judith Curry was another example who weren't looking for a fight, but one came to their door and they stood their ground. And to some extent, I think you're in that category of somebody who couldn't let it continue, even though you knew you were going to get kind of bothered in ways that didn't add much to your life.
Yeah, it is for in the climate issue for me. It's the societal implications. In other parts of my life, in national security, in basic research, in the private sector, I have experience in providing scientific input to decision makers, and I know what best practice is. I have seen it. I was taught it. I practice it. And this was not that. And the malpractice of scientific advising in the climate sphere has tremendous societal implications. $1 trillion being spent to redo our energy systems, for example. And so my passion has been to get the scientific input faithful, accurate, transparent, and that's really what I would like to see. At one level, I don't care which way it comes out, as long as the decision makers, who have to fold in many other factors, accurately understand the science.
And actually, one of my reasons for hope in this field is that I think there are a lot of other scientists who know that something isn't right here, who understand that there are career risks, especially the younger people, but at some point they're going to have to say something. And also, again, putting on my historian's mortarboard, one of the examples that I use when people are worried that this may give ammunition to the enemy is, in fact, about ammunition. In the early part of World War I, there was a public scandal in Britain over lousy munitions. And you can just imagine people saying, don't tell the Germans, don't tell the Germans. But the counter argument, which prevailed, was, we may lose the war if we aren't frank with ourselves about the fact that we've got a problem. And I think that the alarmists have actually put themselves in a weaker position than they seem to, because a lot of people, however informed they may be on the issue, get this sense that they wouldn't tell you if something happened that didn't fit their cause.
I talk a lot in private discussions with decision makers in the government, decision makers in the private sector. And they understand, most of them, and they will agree that the alarmism has been greatly overblown. But up until recently, they've said, we dare not say that in public, lest we be canceled or our companies be trashed or whatever. I think in the last 6 months, things are starting to change. And there is a hunger for a straightforward, honest discussion. I'm finding, and people like Judy Curry or Ross McKittrick, uh, John John Christie, we are finding more people willing to hear what we have to say.
Yes, and in fact, for a long time, I was briefly involved in politics, and it went about as well as people who know me would expect. But one of the conversations I had over and over again with the people on the public side of it, I was a staffer. They'd say, we can't propose this idea. There's no constituency for it, and I would say, nobody's ever suggested it. That's why there's no constituency. Why don't you try? And on the climate issue, I have had discussions with a Canadian premier, for reasons of anonymity, let's call her Smith, where I said, you've got to challenge the science. It's not as certain as they say. And she said, John, we've lost that argument. And I'd say, when did you ever even have it? You've never tried. But in any case, do you want on your tombstone, maybe I should have said something? Or do you want to have this feeling like, well, I saw there was something wrong and I said something. See something, say something.
Yeah. So I think the way this is going to play out is that the energy transition, as people have tried to reduce emissions, is running into a lot of trouble. And it's running into a lot of trouble because it's expensive, it's disruptive, and it really hits the economy, as the UK is understanding. And given that difficulty, the political mood will turn against it, and people will ask, tell me again why we're doing all of this. And that is what's leading to, I believe, a re-examination of the climate science.
Yeah, and again, partly because instead of telling us, look, we have nothing to offer but blood, toil, sweat, and tears, it's going to be a long, hard slog, they said, oh, it'll be marvelous. It'll be like those videos in Epcot Center. Your life will actually get better. But, one of the things in my Offend Everybody plan is to insist that it's not just people we disagree with who can be stubborn or unreasonable. So I wanted to ask you about two things that you wish people would stop saying, one from the alarmist side and one from the skeptical side. What are two common things we could really do without in this debate?
Stop using the words existential, crisis, catastrophe. All right, it's not that. The science does not support that. And on the alarmist side, stop using those words because you are over egging the custard. And on the skeptic side, I would say stop using the words hoax, conspiracy. Climate change is not everything, but it's not nothing. Right? And so we need a middle ground.
Those words are music to my ears. I cannot. I actually have a cut and paste comment because I have to make it so often about it's a fraud, it's a hoax. To say when people say things you disagree with and do things you disagree with, the explanation is they think things you disagree with. And I can't believe that anybody, if anybody's been married, is surely aware that occasions will arise where somebody doesn't agree with your opinion even after you tell it to them, right? So why should it be different in economics? Why should it be different in climate? And if you start to think, okay, well, it's a hoax, then I'm going to get this villain somehow, I'm going to reveal their nefarious plot, versus why does this person not understand the matter as clearly as I'd like them to? And how can I help them, or at least people listening to us arguing, to see what's not right about their opinion? And again, I also have to remind people, like when they talk about the WEF, there's an important difference between a plot and a plan. If they have conferences, say what they want to do, write books about it, and tell you about it at every opportunity, they're not in a conspiracy. They just disagree with you.
In science, we have norms and procedures for reconciling opinions, or at least understanding the root of the differences. And it starts with the data. Unfortunately, the great majority of the public and many decision makers are not trained as scientists. And so even when you show them the data, no long-term trend in hurricanes, for example, they don't understand the significance of that. And so I think we've got a lot of public education that we need to do just about the basics. And frankly, most of the media do not help at all in that regard, because they make their money by clicks and eyeballs, and catastrophe or impending catastrophe is a wonderful way to achieve that.
Yeah, there is an institutional problem, certainly. Although I would point out to the press that they seem to be losing audience, so maybe their plan's not working. But at the risk of having you give away your next op-ed instead of selling it, you segued perfectly into what I was going to say next, which is, if you had a chance to tell journalists, here are some things you need to understand about science and scientific findings, and I'm going to throw in error bars. What briefly would you tell them? Make sure you know what these things are before you tackle the next specific story.
Yeah, so that's I actually have a chart which I use when I'm teaching and occasionally in public talks of things to watch out for, right? So the first is context. And there's historical context. Again, as we were mentioning, if they say it's unprecedented since 1960, ask what happened before. The second is scale. If they say this is equivalent to taking 1 million cars off the road in terms of emissions reduction, ask how many cars are there to begin with. And in the US,
I have
is
no
about
idea.
240 million. Okay.
All right.
All right. So a million is not that big a deal. All right. So dimensionless thinking is really important. In fact, I was thinking about an op-ed about scale and thinking in dimensionless quantities as fractions rather than being impressed by 100 gigawatts, right? So those are two. A third is just look at the data, okay? If they say sea level is accelerating, well, maybe that's true for the last 20 years, but you can find comparable accelerations if you go back to the 1930s, all right? And when human influences were much smaller. So that tells you, again, a little bit of skepticism to say, aha, that's humans. Another is to seek out divergent opinions. And, with the web these days, you can find credible divergent opinions. I like Judy Curry's blog. I look at what's up with that, which is sometimes good and sometimes not. But at least it makes you think and not accept unthinkingly what you're getting in the media. So those are some of the things that I think journalists could easily practice. But, they're non-experts. Most of them are trained in journalism, and most of them don't have the time and have to produce stories that get clicks and eyeballs. So it's a little bit, discouraging the way the media play in this business.
Yeah, and by the way, a sort of a geeky thing that when I was reading the book, I was just rereading it to prepare for our talk, and then I was like, "Oh, that's so obvious," because you were saying some people wonder how it can be that relatively small changes in insulation could produce these large percentage changes in temperature. And then he said, well, that's because if you're thinking in Fahrenheit or Celsius, you're just looking at from the freezing point of water up to where we are now. Think Kelvin, and you suddenly realize it's a much smaller percent change in temperature. And that was, okay, I shouldn't have needed to be told that.
So that's a good example of physicist thinking, all right? You always look for scales and commensurability. A 1% change in the radiation flow is going to make a 1% change in the temperature, except you got to use the right temperature scale. And when you do that, you see it's about a few degrees Celsius.
Yeah, and it was another interesting example was because you pointed out in the book that although it's true that sea level rise seems to have accelerated in the last 25 years, there were other periods, comparable periods in the 20th century, and it was just as fast. And someone said, "Oh, he's cherry picking. If you compare that 25 years to this 60 years, they're different." And I thought to myself, that is not the sort of thing that should have found its way into print without somebody at least taking a sort of skeptical look at why they took your 25 to 25 and thought 25 to 60 would be better. But again, I went into journalism partway through my career. I did not go to journalism school, thank goodness. And I've always had the view that journalism is a craft, and if you're cut out for it, you can be taught the craft in 6 months. But for heaven's sakes, get something into your head, because you will be writing to deadline. You will be scrambling to cover stories that you weren't expecting, and you need background knowledge. And again, if I was making a reading list, one of the critical books would be How to Lie with Statistics. Not because I think they're lying, but because people very often mishandle statistics, but because they just have never been given an elementary course in how to use them to understand reality better, not worse.
Right. I talk a lot to undergrad students and sometimes even grad students. And when I go through issues like that, or go through the actual data in the climate sphere, their eyes open up and they say, wow, I never knew that. And they come away with at least an open mind, if not a changed mind. So one can do that. We've just got to get the material out there and get people who are seriously interested in understanding rather than just parroting what they read in the media.
Yeah. And one way, and this is a bit negative, but again, you talked about this in the book, this curious phenomenon whereby people who are specialists in some particular field, if there's a news story about their field, they will be indignant at how preposterously wrong it is. And then they'll watch the rest of the news or read it and just take it all as gospel. And my roommate in graduate school, actually, he was a paleogeologist. And so if something like that came up, he'd be, no, this is terrible, this is wrong, what ignoramuses. And then they'd start talking about politics, and he'd be like, yeah, okay, and I'd be saying, no, no, no.
Yeah. Yes. So that anecdote involves Michael Crichton, who was, of course, a wonderful science fiction author, and he coined the term for it, Gell-Mann's amnesia, because it arose from his conversations with Murray Gell-Mann, who was a Nobel Prize-winning particle physicist at Caltech. They were great friends and had wonderful conversations together.
And oh, by the way, I wanted to say, if anyone wonders if someone's a physicist, if they call him Dick Feynman, yeah, they're a physicist. So to continue on this theme, what journalists should know, but to flip it into what journalists should know they don't know. One of the things that, again, in the book, you go through so many things where people think they know. This is happening, that's happening, the other thing is happening, therefore there's a climate crisis. And what would you say are the top 3 or 4 things people know that ain't so, that they'd understand the complexity of the issue better if they realized that it's just not the case that we can say this is happening, caused by climate change, case closed?
And in some cases, it's a quantitative misunderstanding. In other cases, it's a qualitative misunderstanding. So you can take the most recent IPCC report, AR6, which came out about 4 years ago, 3 years ago, and there's a table in there, in the back of the report, certainly not in the front, that shows about 30 different kinds of extreme weather events, droughts, floods, storms, etc. And the table says whether we have seen a trend in that particular event. And almost all of the entries in that table are blank. Namely, the IPCC cannot find an observable trend in almost all kinds of weather events. Yes, the average temperature is going up, and maybe there's something in heat waves, although not in the US where we have good data. But so the extreme weather is not getting more extreme over the last century or so. There are ups and downs, and you can find particular regions where something's happening, but globally, that's not the case. So I would say that that's one. A second misperception is that sea level is surging, all right? Global sea level is going up, if you believe the satellite measurements, at 3 millimeters a year, which is a foot a century, all right? This is not a catastrophe. We have adapted to that kind of rise easily over the last century or so. So again, sea level rise, not a catastrophe. And the third, of course, is that agricultural productivity is getting worse and more people are dying from weather events. Just not at all the case. The economic losses from extreme weather are at the few tenths of a percent of GDP. So nowhere do we see that the climate is broken or that it's causing all kinds of havoc in society.
Okay, and now, as I say, we are not in the fortunate position where our thinking and our morals are pristine, and it's only the other people who have mental flaws. So I want to ask, because I think that you believe that there's a somewhat larger human impact on climate than I might argue that there is. So what are your reasons for thinking that there definitely are ways in which we are measurably altering the climate, and which of them in particular would you think are worth worrying about?
Yeah. I would go back not to the changes in the climate, but to the influence on the climate. So I like to think about it like humans exert an influence on the climate, and then the climate responds. I think we have a pretty good handle on the human influences due to rising CO2 and other greenhouse gases, methane in particular, but not such a good handle on the aerosols, which exert a cooling influence. But we have direct satellite measurements of how the carbon dioxide in the atmosphere is making the atmosphere's cooling power, its ability to let the heat out, a little bit less. And that's real. And on the grand scale of things, that's about 1 watt per square meter, and it would raise the temperature by about 1 degree or so. I'm sorry, it's about 2 watts, 2.5, and would raise the temperature by about 1 degree. There are feedbacks. which is part of the response. Where if the planet gets warmer, there's a little bit less snow and ice, there's more water vapor in the atmosphere, there are more clouds, things like that. And that's where the uncertainties are. So I think we know for sure that increased CO2 exerts a warming influence on the planet. And if it weren't for feedbacks, it would be about a degree warming. Not much to worry about at all. But it's these feedbacks that we don't understand that create the uncertainty. So, that gives me some sense that we're certainly having some influence on the climate, at least as far as the temperature goes. But in terms of all the other stuff having to do with extreme weather, we don't see any signal at all.
Now we are coming to the near the close of the program, but before we get there, I wanted to ask you two questions of a technical sort. One particularly because you're, as I said, a theoretical physicist, and it's how accurate the satellite measurements of sea level are. But the other one is that there's something in the book that I've heard from other people, including then Prince Charles, that the carbon cycle basically absorbs all the natural carbon and about half the human emitted carbon. And I have never been able to understand how it tells the difference. It seems to me that if 95% of the carbon that's emitted is absorbed, it should be absorbing 95% of the natural and 95% of the human. So I want to ask you those two. How reliable are the satellite measures, and why is this 50% figure credible?
All right, so let me do the satellite measures first. They flop around a lot. A couple years ago, there was a paper that said sea level is actually decelerating, and it's rising less rapidly as the years go on. And now with more years and maybe better understanding of the satellite characteristics, they say it's accelerating. I, you know, the satellite measurements themselves are no better than, I can't remember exactly what, a couple centimeters. Pretty big on the scale of changes we're trying to measure. So I think that's a technology I'd like to see mature some more, despite the fact that they say they've got it under control. I put much more credence in the tide gauge measurements because, after all, that's measuring sea level where it matters to us, where people are actually living. And for the long tide gauge records, those that have more than 100 years, for example, at the tip of Manhattan in the Battery, they don't show any acceleration at all. They show ups and downs, but gradually the sea level is, of course, going up in most places around the U.S., but the rate goes up and down. And the net is still about 3 millimeters a year. So we've got to be able to reconcile the satellites with the tide gauges, and I don't think we've been able to do that yet, frankly. On the carbon cycle, the physics is the following, that each year about 200 gigatons of carbon go up and down between the Earth's surface and the atmosphere due to the seasonal cycle, plants growing and decaying and so on. It's about 80 gigatons in the ocean, 120 gigatons on the land, more or less in equilibrium, up and down. We are adding to that annual cycle about 10 gigatons a year by pulling fossil fuels out of the ground and deforestation. And it turns out that long term, after a year or two, only about half of what we add gets added or shows up in the cycle. In other words, the increase in CO2 in the atmosphere is only about half of what you would have expected from what got emitted or added to the cycle. The rest of it is enhanced absorption by the surface, the plants, and by the oceans. The fossil carbon that we're adding, the coal, oil, gas, has a different isotopic signature than does the background, if you like. It's a little bit richer in carbon-12 than the background, and proportionally a little bit less in carbon-13. So we can kind of track this carbon we're adding through the isotopic ratios. And that's how we kind of understand the carbon cycle.
And that's actually a very nice note to go into our conclusion on, because I have seen recent studies where people are saying actually it looks as though there's more weathering of rock that's releasing ancient carbon, so carbon that resembles the signature of burned fossil fuels. But that's just a study. And in fact, okay, I find that congenial, but that doesn't mean it's true. It means we should look into this more. And that is so much of a theme of what you've been doing in the book and in the report and in so other fora, is to say, let's not be more dogmatic in our presentation than we have a right to be based on what we know. And again, as someone who's been in a lot of public policy debates, and I've sometimes succumbed to myself to the temptation to be a little strident, it's such an important reminder that you can be very firm on what you do know, but you got to be firm on what you don't know. And you need, again, as you've said, to devise policy responses that don't assume omniscience, because this is a quality of the Almighty that we create.
Although in the end, you have to make decisions. And not only do you have to rely on the certainties or uncertainties in the science part, but you got to throw in values and feasibility and collateral effects in any policy you put into place. It's a lot more complicated than the science, and I'm glad I don't have to do it.
Well, as I think of that scene in The Longest Day, and of course it's true to history, when they have to make a decision whether to launch the D-Day invasion on June 6, 1944, and one of the problems is the weather has suddenly turned terrible, that it's basically midwinter in the Channel, and Eisenhower had written one speech taking credit for the success and one taking blame for the failure and resigning. And I was getting ready for this webinar. I was reminded of a line from Treasure Island where in the crisis, one of the pirates says, "I'd just like to know what's what." And one of the others says, "He'd be a lucky man as knowed that." But it's really important to know what you don't know. And the final thing I want to say, and thank you very much for being on the show and sharing your expertise with us, thank you for your courage in speaking out, because I think that it is so important on almost any policy issue that if you know there's something wrong with what's being said or with the way things are being done, you know you're going to take some heat for saying it, but we need people to stand up and say it. So I thank everybody for watching, and again, thank you very much to Stephen Koonin, who is a climate scientist and not one of the usual suspects, for everything that he's done, including joining us tonight for this fascinating discussion on what we know, what we don't know, and why it matters. Good night, everybody.